I'm Juan Sher, one of the scientists here at Microorganism Laboratories. I want to introduce you to a restroom infection control product called Restroom Guardian. It's claimed to be the first product developed to virtually prevent and eliminate airborne cross-contamination for both bacterial and biohazardous agents. Let's take a closer look at this product. A toilet bowl was filled with liquid detergent that acts as a highlighting agent under UV light. Two phases were conducted in this experiment. In the first phase of the experiment, normal airborne cross-contamination sourced from a toilet or urinal was demonstrated. Parts of the wall and the floor were lined with paper followed by exposure to UV light to demonstrate that the restroom was clean. As you can see, the toilet rim, the wall, and the floor are clean. Here's another picture. This was paper lined above the toilet tank. It's also clean. Then water was poured into the toilet. Want to see the results? So I went ahead and made some arrows to make it easier for you to see. I know, you're welcome. So you see a bunch of microsplatter along the toilet rim. And in this picture, this was the paper located above the toilet tank. This picture was some of the splatter on the floor. Now, I never knew there could be that much of a mess, but I'm definitely disgusted. Good thing it was just water. The second phase of the experiment was to demonstrate the effectiveness of Restroom Guardian in preventing airborne cross-contamination. Like the previous setup in phase 1, the entire restroom was thoroughly cleaned and lined with new paper along the floor and the walls. The room was exposed to UV light to check its cleanliness. Now, a single dosage of Restroom Guardian was added into the toilet along with the biodegradable packet. The Restroom Guardian immediately creates a splatter barrier on the water surface that prevents microsplatter from occurring. Water was then poured into the toilet, and here were the results. That's the only microsplatter found on the toilet rim. Pretty amazing. Let's check the walls. You see some on the wall, but not as much as we saw with phase 1. Let's check the floor. I don't see anything. Do you? Well, it looks like the toilet and the walls and even the floor look pretty clean to me. As any good scientist may know, a single test isn't good enough to prove its effectiveness. That's why the scientists here at Microorganism Laboratories have come up with another experimental setup. This experimental setup is also going to have two phases, but instead of adding liquid detergent into the toilet bowl, we're going to spike our toilet bowl with Pseudomonas fluorescens. In the first phase of the experiment, normal airborne cross-contamination sourced from a toilet will be demonstrated. The walls and the floor of the restroom will be lined with butcher paper and then with labeled paper towels. Then an appropriate amount of water will be poured from a normal height into the bowl. Now, upon completing the experiment, we will take each paper towel and mix it well with our stomacher machine. We will then take 100 microliters of the sample and plate it out on Pseudomonas fluorescens agar, along with a 24 and 48 hour follow-up incubation plate count. In the second phase of the experiment, we will demonstrate the effectiveness of the Restroom Guardian in preventing airborne cross-contamination. The entire restroom will be cleaned and lined with new butcher paper and labeled paper towels on the floors and the walls like the previous phase. We would then add the same amount of water from the same height. We would then mix it up well, plate it out on agar, and then do a 24 and 48 incubation follow-up count. So let's head on over to the restroom of Microorganism Laboratories to meet Dr. Bruce Hemming, President and CEO of the lab, to demonstrate this experiment.
Hello, I'm Bruce Hemming, Dr. Hemming, President and CEO of Microbiotech Labs. As Juan explained, this experiment is done in two phases. In phase 1, we spike the toilet with Pseudomonas fluorescens as an easily detectable bacteria we are using to demonstrate normal airborne cross-contamination from toilet use. Next, we turn on an air sampler and pour water into the toilet from a normal height to simulate it being used. The sampler collects the splatter and water being caused by the water being added to the toilet. Sterile sponges are used to collect the microsplatter on the rim of the toilet here. The underside of the toilet seat is also sampled, and inside the toilet bowl, the paper towels around the toilet are collected and are tested along with the sponges for the presence of the bacteria. In phase 2, the bathroom is reset with clean paper towels and the experiment is repeated. This time, however, we will be adding the Restroom Guardian product. First, the Pseudomonas fluorescens is added to the bowl. Next, Restroom Guardian is added to the toilet and it immediately reacts with the water, creating a foam barrier about 2 to 3 inches thick. Water is again poured into the toilet from approximately the same height, and the air sampler is turned on to collect a new sample. Clean sponges are again used to collect samples from the toilet rim and underneath the toilet seat, and again inside the toilet bowl, and the paper towels are collected for testing. How did Restroom Guardian fare? Let's look at the results. If we look at the plate counts, test 1 inside toilets around 10 to the 4th, and at the lip of the toilet is 10 to the 6th, so there's plenty of bacteria there. Here we have all the different sites, and you see on the left hand the first test without the Guardian having a lot of too numerous to count. We also conducted a kinetic assay looking at the growth of the Pseudomonas with citric acid. If we take the data and look at it closer, you'll see that the citric acid does inhibit the growth as shown in these curves. Here's a bar chart as well that shows that 0.2 grams per 10 mils definitely inhibits the bacteria somewhat. It's not a bactericide per se, but it certainly does help reduce the bacterial growth. We appreciate you watching this video and how we've conducted this test. It's also possible that we could extrapolate that had we placed the bacteria in the bowl initially, that it could simulate a radiation-like treatment and the microsplatter that would occur there. I would think that it would be just as effective as shown with the UV light treatments by our client. Well, thanks again, and if we can help, give us a call. Microbiotech Labs, 800-688-9144, or at www.microbiotech.com. Thank you.